For many use cases, it can be useful to have a coordinate system to place your chart in. So now let's look at how to get one. For that, let's open the example file of coordinate system tutorial. This is a rather large file, which consists of, on the left side, the read file and look at values, which are now a little bit more sorted and structured than in the other file. So this data, and then we have 3 more clusters. One is basically decision making, and one is the coordinate system, and the last one is how to create one headline if you wish to. So the data in here is basically what we have had already. It says read file now and look at values. And the things that we get out of that are basically the same as those we have already looked at. For our example, some of these values first can be ignored now. So as X values, we are going to take the population number, and as Y values, we're going to take the numbers of infections per country. So I've written down here what all of this, all of these values and all of these toggles in here do. Nevertheless, I one time want to go with you through it. So it says start here, so let's look here first. We have our X values. We can simplify them to have a more beautiful number, and we see it's calculating now and it's taking some bit. And we have also our Y values now, which also can be simplified. And while that is loading, I am also already talking about the Y2 values. And if we now imagine, for example, to have a histogram, it may appear that we can look at two y-axes at the same time, so that you have one y-axis on the left and one on the right, which have two different scales, which is good for comparing two values at one country, for example. So next, we will look at our dimensions. And we see here a lot of stuff that is in there because of the toggles that are down here. That is because I have already built in some things that you can turn on or off. For example, you can turn off the coordinate system as a whole. You can turn on and off your second y-axis, and you can turn on and off a 1-to-1 ratio, which is the middle line between the y and the x-axis. Then as drop down, we have x dimension, which says dynamic or static. And what that means is that you can either choose, which is especially interesting for animations of data visualization or of graphs. You can choose if you want your thresholds and the upper and lower endings of your graph to be always the same value, which you could set here, or you could also look at the values that you are actually giving in and what are the upper and lower ends of these, and that would be dynamic then. What that means is if you have a video of your graph, then you would have axis that is not always static, but it is dynamic and changing with time. In x-axis is you can change if you want your graph to be horizontal or vertically, and then you can set the y-axis from bottom up to top down. What comes after that is more important a little later. We have our divisions for the axes. So when we have created our axes, we want to have some numbers on it and maybe some lines on it. And we can here choose on how fine these values are. Have the whole numbers, have every half number, every quarter number, or every tenth number. And we can do this for x, y1, and y2. And then if that is still too much, we can choose to show only some values on the x-axis. That is what's going in here. So if we now go back and look at the dimensions here, a lot of this is stream filtering or switching and sorting, and basically these are the important numbers in the end: the x start, the y start, and the x end and the y end. And from here on, the values continue to go in your coordinate system. So what else do we have here where decisions are made? I've created a color palette that you could use. For example, you could change just these swatches. For now, that is not connected anywhere, but you could. And we have here some more colors that are sometimes, or in some cases, connected to certain things in your coordinate system. And the font is also something that you should globally set. So this is basically then the very first thing that you should care about. How large is your graph actually going to be? So I have decided to create an HD, so 1080 pixel rectangle in here. There's really not much more in this cluster, but a rectangle with the size and an integer of the width and the height that's going out. And this geometry goes into a bake. And this bake goes to this button. And this button is connected to several other nodes. And these can all be baked by pressing this single button. So this is one workflow that I developed for me. I want to bake everything at once. By pushing of the single button, and the components that Human and other plugins deliver to that are really great to work in that way. So coming back to our frame, we now have our 1080 pixel, 1080 by 1920 pixel rectangle, and then we would want to see to set how far from the edge the frame shall be. And this is another cluster. We set the margin of the sides, of the tops, and the margin to the axis, and set it into this cluster called frame. Let's look into this cluster. Okay, what we have here is basically just some basic math, some subtraction, and giving points into it from the width, the height, and the margins. And creating the points. And these are the points that are created from that. You can turn it off, and we have the lines that are connected by these and give these out and have the frame. So if we want to look at this, this is the frame. We have the margin at the top of 300 and the margin at the sides of 150. And that is what comes out of that. For now, let's turn this off again and just remember the position. And inside of this, we now want to place our axis. And for that, we take all of these numbers and do some basic math with it. And first, let's create the point of 0, which is here, and of the max x and of the max y. And that is a great start for our axes. Put it two lines. This is just a line component, line AB. And then we have here a call pattern. And the call pattern is what connects to these toggles. They are just for culling out everything that you want to show or not show. So these would be then go into the preview. We can turn the preview on and turn all of these off again. Preview off. And we see now the axis. We could turn coordinate system off and we would not see it turned on. It's there. Great magic. So besides going into this preview, well, this preview connects to the shader that we have defined here. This one also connects into this bake component, which is a human component, and it has the same attribute. Oh no, it does not. It has an attribute cluster, and this is simply to save some space. It has this large layer thing and this large create attributes node, and all we need is color and layers. So I made a component out of that. I made a cluster and have this into attributes and save some space in here. The same thing then also goes for the second y-axis. It is turned off and it is not created right now because we don't have any second y values. It would appear here and then go the same way as the others do. So for the next thing, let's look at the text, or all of the text components here. We can again skip y2 text because there's nothing in. That's why that's yellow. Let's focus on y text and x text while they are basically working in the same way. X text has these few things to worry about. It's the justification that you can put into this 3D text cluster, which is basically the same that we have already looked at in the last video. And then we have a distance from the text, which is to move the text away from the axis. And for all of the text, we have the font size and the layer name to bake to. The font is already defined here in this. This is where decisions are made. So then let's look at what this cluster does. This is called axis division. What it basically gives out here is for our x-axis, which we give in, some points and some points away from it. So the axis division needs some inputs, which is the start, so the first point on the axis, the target, which is the last or the largest point on the axis, the round, which is to which value shall this round, which goes back to this quarter, even, half, or tenth. And you will later see what this actually means. The axis is the curve, or basically the line that you give into it. So here the line of the x-axis, and then you can give in some x vectors and some y vectors to move the font away from the axis, and we want to move it in y direction by 25 and make it negative, so it's minus 25 pixels underneath the x-axis. If we look into this cluster, it contains a lot of troubleshooting, to be honest. Down here, this whole thing is just to check if there's an E in the number. So we see that the target, or let's see here, the target is 8.3167 E plus 7. So it's a really large number, and Grasshopper makes this number shorter. And to avoid this from corrupting our measuring of the text, we have to check if there's an E in there. And if not, we can take the pure number, and if we just have to write out the full number as a text, because what we want to do with it is that we want to check the text length. So we have here either a number that is something that we can deal with, or Grasshopper can deal with, or that would come into 0, or we have a very large number coming into 1 and filter that and give it onto this text measuring component. And when we have measured this text length, we have to put the expression of x minus 3 to that, which is due to the way that I have created the rounding function. So I want to have it an absolute number, which is 5. So the text length actually is 8. It's a really large number. And minus 3 is 5. It could be smaller than 1, so that's why we go to absolute. And we repeat now the data of 0 5 times and have 5 times 0 and give a 1 and these 5 zeros in a merge, have it flattened and join the text, and then have the number of 100 and 1000. What we now do is we connect the round input, which is 25 as we want a quarter, and divide it by the 100 and 1000 and multiply it by the 100 and 1000, depending on which it is the number that is larger than 0 or bigger than 0 in here. We have a 5, so this filter would be going to the 0 for this multiplicated value of 2.5 million. So this means that this is our step width. The step width for the maximum of 900 million. Now we want to create our real steps with it. So we look at what is actually the difference between our target, the highest value, and our start, the lowest value. Give this difference out and divide it by the step width, which is then 33.2, and have the lower, so the floor rounded number of that, and do the same thing with the start divided by the step width, round that to the ceiling. And then what we do is we create a series for the ceiling, which is here 1, and multiply that by our step width. This we will get to the start of a series with the step width of our step width and the number of our steps as we got it from the difference divided by step width. And this step series gives out this series of numbers. So sometimes it can be that the first value on your axis is not the first number. So we want to add our first number, which is 38,000, to the axis start, and merge the step series to it, and then have these 34 values that are on the x-axis. So next, we want to have the points on the axis that we can already see here as the upper points. So we want to remap the points that we can see here. And we have our domain of what we got into. And then we want to remap that to a domain of 0 to 1. And we also take the axis and the endpoints and create a vector from that to see how long is that line. It's 1520 in x direction. Take the length of the axis, multiply it by the position we get from the remapping, and move the axis starting point by the motion vector that we just created, and thus have created these points that we then can give out. Now to create the text points, we just have to move them away. We have created these two inputs of x and y and put it into a vector node and move the axis points by the motion vector that we created and give these points out too. So now we have created our text and our points and the points to put the text on. And we have in further processing some call nodes basically, which go back again to these. We can see so we can see the pattern here of should we see every X item or should we see like every second, every third item? And same for the text. So we give the text and the text points into it. And then again, we have the, we measure the max text length. Let's look into that shortly. We have the number of characters, so text length, flatten that, mass edit, and see if that's larger than input number B. And input number B, let's look back, is here set by 150. And that is simply to trigger this filter, which goes to this rotation degree. So if we look into that, this is simply translating from radians and rotating the plane. And this is to rotate the text if it is too long to be displayed next to each other. So if we now look at the text and unpreview these, we have the text in here starting at 38,747 and going back in steps of 25 million, which Grasshopper displays now at these. You can set that somewhere, I'm sure. So after that, we basically do the same thing for the y-axis with the slightly different thing that we say round up. And round up is another cluster. Let's look into that. So what's happening here is similar to what happens in the other cluster. We measure the dimension of the text and repeat some zeros and have the same rounding functionality that we here join the text again to have the 2.5 million, and then divide it by 10. Put that into the step width and divide the target by it. Round it, take the ceiling, and then multiply it by what you got out of here. And then you have the target of your dimension. So to look at that from the outside is we look at here what is the largest item. It's 5 million, and we want to round up until the next step on the y-axis, which is then 5.25 million, and then divide the axis by that. And when we look at the text that comes out, it is this. First value is 2,753, next 2.5 million, and then going up. No, it's 250,000 and going up. So as before, we can spare on looking at the Y2 text. It works the same way as the Y1 text, of course, with different numbers. And then we want to divide our axes to have those small lines where the number should be. And how we do this is this. The start is actually here, here, and here. These are the points on the lines. And then we have factor, which is 5, which is the length of our lines. And we create vectors from that and move the points in the according lines, in the according direction, and then create lines from that. So from these points to the according points on the y-axis. Look again if we want to display the coordinate system and send it to a preview into the bake, and we then see that these are the lines that we have created now. So now for the half angle, which is called 1-to-1 ratio in the large panel, we have to do some math. Basically, we take our starts and our ends and create some points from that. And we will not see those here. I could have spared to try and show the preview because those are enormously large. We would have to zoom out very far. And that is why we have to scale those. We have to scale those with the 0 point from our axis that is here. Let me show you. Oh, yeah. No, it's again, it's just the 0 point. That is the real 0 point, and we have to scale it from the actual 0 point of the canvas, which is the actual 0 point. So now the math we have to do here is subtracting y end and y start and dividing the y-axis length by the y domain and look at if there's negative or positive, depending on whether we have chosen y to be bottom up or top down. Do the same thing for the x-axis, and then we can scale these points. And what that leads to is those are the scaled points, scaled to 0 because we scaled from 0, and then because our 0 point for the coordinate system is not 0 but at 200 and 200, which we give in here, and create a vector from that, we move the points into the coordinate system. Then they appear here and here, create a line between these points, and turn on the preview, and then we have this line. So what this line now shows, whoops, let's turn it on again. What this line now shows is where x and y share the same value. Now we have created our coordinate system on our canvas of HD, and we could now look at how to create a headline. And how we do that is here. First, let's set our top line and make it the underlining for our headline. The top line we have created in the very beginning is this one, and we can just preview it in the shaded number that we wanted to. So now it appears black. And as the start for our text, we want to have the endpoint of the line, which is this one, and move this a little up so the text is not directly on the line but a little above, and put this into the position. The text font is here chosen differently. We could have also put in the font from up here, and size is 9.3, justification bottom left, factor 6 in Y for the move. Basically all you've already known, attributes in the bake, it's all the same. And then the text for it is here, created by a little merge. Actually nothing too crazy. We can choose, for example, what type of graph we want to create and have a filter there. So this is kind of responding to if you choose a variety of graphs in one Grasshopper file, then you could make a drop-down list like one of these and have in there, for example, circle graph or chart or histogram, and then trigger that with the same filter as the headline, and it would give you the according headline to your graph. What is then here is some by and end and some streaks and some items that we have gathered from our data. So this is the list of what columns are, and this is 2 and this is 2. And we have the indices here of what we would show, and it gives us cases and countries and territories and population data. And if we then look at text, preview it, it's here cases by countries and territories and population data, and it would be a chart. So that would be a like slightly generated headline that you could use. Now that we've created the coordinate system, let's take our pie charts for a walk and create a circle graph.